check sequence to the destination. After that, we can add the preamble and SFT. Let me to write here. This is SFT and this is the preamble. Okay. Now we can see all of the process. When the PC2 is receiving the packet, first the PC2 should find the start of the frame with preamble and SFT. When the PC2 find the start of the frame, okay, it can separate the last 4 bytes from this frame. You know that when we are identifying the start of this frame, we can also identify the start of the next frame. Because of that, we have the start and end of this frame. Okay, when the PC2 find the start of the frame, okay, or the SFT and preamble, it can separate the FCS and CRC, and after that, again in the other parts, it can calculate the CRC. If the result of CRC is equal with the result of the CRC in the FCS field, okay, the PC2 can understand the packet is not corrupted and the packet is the frame is noise free. Why? Because if the bits of the frame was changed, the result of CRC in destination is different with the result of CRC in the source. This is a mathematical for example, process. And you know that when the result of CRC is same, this means that we can use this frame. And when the result of CRC is different, the PC2 should discard the frame. Look at here. Assume that as a PC2, we are receiving this frame. First, we should find the start of frame with preamble and SFT. After that, we are separating the CRC. After that, we are calculating the CRC again in this part. And then we are checking there is the calculated CRC with the received CRC. If both of them are same, now we can check the destination MAC. The destination MAC is equal with the destination MAC of, for example, our system, or with the MAC address of our system. Because of that, this packet is for us. Let me to check the type. In type, we can see the IP or 0x0800. This means that we need to give the packet to the IP protocol. Now we can de-encapsulate all of this information: type, source MAC, destination MAC, SFT, preamble, and also FCS, and we can give this packet to the network layer. Now you know the function of the preamble, SFT, destination MAC, source MAC, and type and FCS. Let me to review. The function of preamble is synchronization with 7 bytes. Okay, we are using the preamble for synchronization. The function of the SFT or start frame delimiter, signifying that the next byte begins the destination MAC address field. The preamble and SFT totally are using for the same function. Then destination MAC and source MAC. Okay, destination MAC with 6 byte length identifies the intended recipient of this frame. Source MAC again with the 6 byte length identifies the sender of this frame. Then we have another for example field, the type field with 2 byte, defines the type of protocol listed inside the frame today, most likely identifies IP version 4 or IP version 6. After that, we have the packet. I will talk about the packet, but about the FCS or the trailer, provides a method for the receiving network interface card or receiving device to determine whether the frame experienced transmission error or no. Okay, until now we learned about the layer 2 header and layer 2 trailer. Before talking about the data and path, okay, let me to show you one simple example. The detail of this example is not important for us. I'm going to show you one example about the Ethernet frame. You will see this Ethernet frame with more detail in this course, okay? But let me to give you one example. Assume that I'm going to use 2 PC. This is the first PC, this is the second PC, okay? And then I'm going to add 1 switch. I know that I didn't talk about the switch, but let me to show you one example. Again, I'm going to emphasize that the detail is not important. We need to use the straight through cable because we are connecting the switch to PC. And you know that for connecting the switch to PC, we need the straight through cable. Let me first connect this, for example, cable, this twisted pair cable or a copper straight through cable to the switch port, and then to the computer, again to the other ports. You will learn about all of things here. For example, what is the name of the interface, why this color is orange and why this is green, and after some second you will see that these colors should be converted to green. Look at here, now both of them are green. Okay, now let me to give this PC one IP address. Again, you will learn about the function of the IP address and relation with the MAC address. The IP address of this system now is 192.168.1.1. okay, we can write it here, 192.168.1.1/24. This is the IP address of this PC, and also the IP address of this PC is 192.168.1.2/24. You know that each of them has different MAC address. Okay, here 192.168.1.2. Then now I'm going to sending one packet from the PC1 to PC2 with ping command, ping 192.168.1.2. As you can see, we expect to receive the for example result, and then okay, yes, we have a reply. Now I'm going to show you the Ethernet frame. Look at here, this is the Ethernet frame. We need to filter only, for example, ICMP packets, and then this is the packet again sending the ICMP packets. Now we can see the packet, and inside of the packet, as you can see, we have the layer the Ethernet header. Now I'm going to show you the detail. This is the detail of the Ethernet header. Look at here, this is the data or the packet. As you can see here, we have FCS. The content of FCS is not important. This is simulator, but we can see the data and the layer 2 trailer. Then we have type. Then we have source MAC address. This is the MAC address of the PC1, and this is the destination MAC address or destination address, the MAC address of PC2, and then SFD, and then preamble. As you can see, now we can understand the functions of the Ethernet header and Ethernet trailer. Also here you can see the Ethernet 2. Let me to give you one explanation about the Ethernet 2. The first Ethernet, okay, was released with 3 companies. Let me to write here. This is only for your information. 3 companies, Digital, okay, Digital, and Intel, and Xerox, okay, in the old days of the networks, okay, was creating the Ethernet. And we call that Ethernet the DIX Ethernet. We call it Digital Intel Xerox Ethernet. After some days, this Ethernet changed to the Ethernet 2 with some modification, okay? And you know that the IEEE released the standard of the 802.3 for Ethernet. Now, we have the Ethernet 2 in our networks, and also the IEEE 802.3 now is compatible with this Ethernet 2. Because of that, maybe you see in some documents or in some captures of the traffic, such as the captures that I showed you, the Ethernet 2 or IEEE 802.3. The detail is not important for the CCNA level course. Because of that, you know that the Ethernet 2, Ethernet, or IEEE 802.3, all of them are same, and all of them are meaning the Ethernet. And because of that, if you see these terms, you can for example, understand the function or the reason of this. Very good. Another important thing about the Ethernet and Ethernet, for example, frame is this part. Look at here. Here we have data and path. And as you know, the data is the packet that we are receiving from the network layer. Okay, you know that we are receiving the data from the network layer. And after that, we need to add layer 2 header and layer 2 trailer, you know, the function of these two part. And after that, we can send it. But what is the path? Okay, the path is nothing. Means the path is many zeros in most cases. Why we need to add the path? Let me to show you. Assume that we have a data. This is our data, 1110010. Okay, this is our data. Okay, in some cases we need to add some zero or padding with some zero this information. Why? Because in some cases the size of the packet, okay, is less than the minimum size of the Ethernet frame. Okay, you know that each frame has a minimum size and has a maximum size. For example, for Ethernet frame, this is an Ethernet frame, all of this is Ethernet frame, the minimum size is 64 byte. Okay, the minimum size is 64 bytes. Now let me to count the bytes of the header and trailer. For example, in header you shouldn't count the preamble and SFT. This is not important for us. Okay, this is only for synchronization. These two fields are only for synchronization. Here we don't have any data, you know it. Okay, the destination MAC has 6 bytes, the source MAC has 6 bytes, and the type has 2 bytes. This means that we have totally 14 bytes in destination MAC, source MAC, and type. I can write it. Look at here, 6 plus, okay, 6 plus 6, then plus, okay, 2, and after that we need to add the 4 byte here. Finally, the layer 2 header and layer 2 trailer without preamble and SFT should add 18 bytes, okay, to the packet. Assume that this packet has the size of, for example, 30 byte. When you are adding 30 byte to the, when you are adding 80 bytes to the 30 byte, the 18 bytes to 30 byte, finally we will have 48 byte frame, and this size is less than the minimum Ethernet frame size. Because of that, we need to pad it. The minimum frame size, the minimum data size is 46. Why? Because when you are adding 18 bytes to 46 byte, you will have 64 byte. Because of that, if your data means the packet we are receiving from, this is not this data, okay, this data means the packet, the result of the for example layer 3 of the TCP IP. When you have a packet, when you are receiving a packet with less than 64 byte, you need to add that packet with the pads. Pads means 0. Okay, after you reaching to the 64 byte, you can add the type, source MAC, destination MAC, FCS, SFT, and preamble. Okay, because of that, now you can understand that the data and pad can be minimum length of 46 byte. Okay, and after that we have another limitation about the Ethernet frame. The minimum Ethernet frame size is 64 byte, you know it, okay? And also we have another limitation, the maximum Ethernet frame size. The maximum Ethernet frame size is 1580 bytes. Because of that, okay, because we have 80 bytes of the, for example, Ethernet header and Ethernet trailer, finally we can have the 1500 byte of the data and pad. If you have more than this data, you need to send with another frame, okay? Until now, you learned about the reason of the pad. And also, you know that we are using the pad to increasing the size of data to minimum 46 byte because we need to send the frame with minimum 64 byte. Maybe you ask me why we need to send the Ethernet frame with maximum 1580 byte. This is a little beyond of this course, but let me to give you one notation. Assume that this is the network interface card, or this is a port of a networks. Each network interface card or each interface or port of a switch has a value, has a characteristics. We call it MTU. What is the MTU? MTU is the abbreviation of the maximum transmission unit. Means the maximum packet size that we can send from this interface. Okay, this is the capacity of this interface. We can send more than this size from this interface, and the MTU in most cases is 1500 bytes. Okay, maybe you can increase this, but in most cases we are experiencing the 1500 byte. Okay, this is the limitation of this interface. Because of that, this is the size of packet. Don't forget, maximum transmission unit is the maximum size of packet, not maximum size of frame. Here, because of that, you can see 1000